Okay. Chapter 4, sections 1 through 3, review packet 2. Do we have questions over 1 through 6? Please name your problem. Give me a specific problem. Number 5? Number 2. Okay, number 2. I have 9 pi over 4. And it says, evaluate the 6 trigonometric functions of the following using its period as an aid. Now, guys, here's what you need to understand. If you look at problems 1 through 6, look at all the denominators. The denominators are dead giveaways as to the point that you're referring to on your unit circle. So what is the denominator of this one currently? It's a 4, which means that I'm referring to, and there are 2 R's there, referring to an angle of pi over 4, right? Well, what ordered pair goes with pi over 4? Square root of 2 over 2, comma, square root of 2 over 2. Now, we're not done because it's not necessarily saying that that's the ordered pair. What I'm saying is that is the numbers, and then what's going to change possibly is the positive or negative values of them. Does that make sense? So we need to determine the quadrant in which we're in. So the way we're going to do that is we're going to have this denominator 4. We're going to say 2 pi is equivalent to what with the denominator 4? 4 times 2 is 8 pi over 4. So what we need to do, okay, is we need to find the coterminal angle between 0 and 2 pi. Yes? Now, all I have to do is subtract 8 pi over 4 from here, and that's going to give me pi over 4. Pi over 4 is the coterminal angle to 9 pi over 4, which means what? That it is, we already knew it was a 45-degree angle, but it is actually 45 degrees, which means it's falling in quadrant 1. So if it's falling in quadrant 1, the sine and the cosine in quadrant 1 are what? Both positive, which means this is what you need to know. Sine of 9 pi over 4 is positive square root of 2 over 2. Cosine of 9 pi over 4 is positive square root of 2 over 2. The tangent of 9 pi over 4 is 1. So now what is the cosecant of 9 pi over 4? But we got to rationalize that. So yes, it's 2 square root of 2 over 2, but that's going to be what? That's, sorry, I wrote that wrong. 2 over the square root of 2. So if we rationalize that, that's going to be what? 2 square root of 2 over 2, which gives you what? Square root of 2. Do we understand that? Yes or no? We good on that? I actually have that filled in for you already. Does that make sense? Okay. She asked, am I going to mark it wrong if she doesn't have sine of 9 pi over 4, cosine of 9 pi over 4? Are you with me? And I will not mark it wrong because I was nice and put those in for you, so all you had to do was fill out the actual values, the function value. Okay? All right, so what's going to be the cosine of 9 or the secant of 9 pi over 4? Square root of 2. And what's going to be the cotangent? It's still going to be 1. Do we all understand problems 1 through 6? And yes, you're going to have a problem like that tomorrow on your test. Okay, problems 7 through 12. Questions over 7 through 12. 11. 11. The sine of theta is equal to 4 over 5. Now, here's what I need your brain to understand. If I'm talking about the sine of theta being 4 over 5, this is saying that the sine value is positive. Well, the sine value is positive in which 2 quadrants, folks? The sine value is positive in quadrant 1 or in quadrant 2. Would you all agree with me with that? Yes or no? Okay. Well, letter B says, or letter A, sorry, is the sine of pi minus theta, which is equivalent to the sine of negative theta plus pi. Agree with me? Would you agree with me on that? Okay. Now, if the sine of theta is in quadrant 1 or 2, that's theta. Where's negative theta at? Has to be. Do we understand that? Yes? So here's negative theta. Okay? Negative theta is going to be down here. Yes? Okay? So if we're at negative theta, and let's say we're in quadrant 4 for negative theta, and I take and I add pi units to that. Remember I did this? Remember I had my nice little yardstick here? I said I'm in quadrant 4. If I add pi units to that, where's it going to land me at? If I'm in quadrant 3 and I add pi to it, where's it going to land me at? Quadrant 1. So tell me, what is this value going to be? Remember, whenever you added pi units to it, it was going to be where? The diagonal quadrant from where it was currently located, right? So if I'm at negative theta and I add pi units to it, negative theta has a negative sign value. So if I add pi units to that negative sign value, where's that going to land at? Quadrant 1 or quadrant 2, which already has a positive sign value of 4/5. So the answer to this is going to be 4/5. Because if I'm down here, let's say this is negative theta, and I add pi units to it, that puts me over here, and my sign value up there is going to be positive 4/5. Do we see that? Yes or no? Okay, part B. Part B says to take the sign of what? Okay, well, this is talking about being in quadrant 1 or 2. It's the same exact concept, except for this time, when I'm in quadrant 1 or 2, my sign value is positive 4/5. And if I add pi units to that, where am I going to land at? I'm either going to land in quadrant 3, which has a negative sign value, or in quadrant 4, which has a negative sign value. So this is going to give me what? Negative 4/5. Do we all understand that? It's basically adding a half circle to it. Yeah. It's understanding that if you're in quadrant 3, adding pi units to it makes the sign value become positive. If I'm in quadrant 2, adding pi units to it makes it turn to a negative sign value. Because the signs for all of theta are still going to be 4/5, right? Yeah? It's a matter of determining if it's positive or negative. The directions are going to be the same no matter what book you use. It's you need to understand what quadrant you're in and what that is representing of the quadrant that it lies in. Okay, the diagonal quadrant. The diagonal quadrant. Okay? Now, I don't want you to focus on problem 11 and 12 as much as I want you to really focus on problems 7 through 10. Because problems 7 through 10 are really, really important for you to understand. Did you ask me which one, please? Probably not until the end, but I will if we have time at the end. Number 8, the sign of negative theta is equal to 3/8. Okay? So part A says to now find what the sign of theta is. Now, do you remember we had our even and odd functions? Our even and odd functions were introduced to us back in section 4.2 on page 263. Section 4.2, page 263. And it says that sine is going to be an odd function. Do we understand that? If you're an odd function, this says the sine of negative theta is equal to negative sine of theta. Do we understand that? Yes or no? So what would the sine of theta be equal to? So if you get that, it absolutely is going to be negative sine of negative theta. Well, what is the sine of negative theta? It's equal to 3/8, so it's going to negative 3/8. Do we understand that? It's simply applying that odd function concept, okay? It's simply applying that odd function statement over there. Okay, letter B. Now it wants you to find the cosecant of theta. Well, what do we know the cosecant of theta to be? The opposite of sine. So what's that going to be? -8/3. Do we understand that, yes or no? You have to apply this right here. Remember whenever I taught this, I did this? Remember that? I said if you were in quadrant 1, this was theta. However, if you're in quadrant 2 or 4, sorry, this was negative theta. Now, how did I go from having a positive sign value to a negative sign value? Well, that's saying that the sign of negative theta is equivalent to negative times the sign of theta. Well, it told you that the sign of negative theta was equal to 3/8. That, it doesn't matter about which quadrant you're in this. It matters about the fact that you're applying this right here. Okay? Does that make sense? Because right here, it's going to tell me that in order for my theta that's negative to be positive, I have to be in quadrant 2 or 3. I'm sorry, 1 or 2. You with me? I pointed to them, but I didn't say it correctly. Yep. Okay? Do we understand that? All right. Next set of directions is going to be 13 through 16. So if we're looking at section 13 through 16, it's talking about complementary and supplementary. Agree? Folks, look at number 13. What is my complementary for 13? Why is there no complement to 11 pi over 13? Because it's over the level little 90. You with me? So there is none. Now, what is my supplement? 2 pi over 13. Number 14, what is the complement to 9 pi over 14? There is none. Why? It's over half. Half of 14 would be 7 pi over 9, or 7 pi over 14. And clearly that's over that, right? If you want to, absolutely. Most importantly, though, if on the test there is none that exists, what do you write down on the blank? None, okay? Now, for number 14, what is the supplement? What is the supplement to 14? 5 pi over 14, good. 15, complement of 37 degrees. I'm sorry? The complement of 37 is 53 degrees. What is the supplement? 143. Number 16, what's the complement of 152? None. And what is the supplement? 28. Do we all understand those? Yeah. All you're doing is taking 90 minus the angle or 180 minus the angle. That's it. You cannot do a complement of 9 pi over 14. Okay, let's say, for example, I had 3 pi over 7. Well, what would be the complement of that? Well, that's going to be taking pi over 2 minus 3 pi over 7, which is going to be a denominator of 14, right? So that's going to be 2 pi, and this is going to be 6 pi. Can I do that? I needed a I didn't write this down. I wrote that as a 2, and it should be a 7. I'm like, why can't we do that? Okay, so what's 7 pi minus 6 pi? Pi over 14 is going to be the complement. Do you see that? Who asked for that? Do we see that? What's the common denominator between 2 and 7 is 14. 2 times 7 gives you 14, so 1 times 7 gives you 7. 7 times 2 gives you 14, so 3 times 2 gives you 6. Subtract the numerators, you're going to get 1. Keep the denominator, it gives you 14. Okay, we good on that? Okay, we good on complement and supplement. It's going to be on the test tomorrow. Okay, the next section is going to be 17 through 20. 17 through 20, talk to me. 17. The cosecant of theta is equal to the square root of 13 over 2, and the secant of theta is equal to the square root of 13 over 3. And it says use the given function values and the trigonometric identities to find the indicated functions. It wants you to use your identities, right? Okay? If it wants you to use your identities, then you need to utilize that. The first thing I want you to do is to find the sign. Well, how do I find the sign? So what's that going to be? 2 over the square root of 13, rationalizing that, gives me 2 square roots of 13 over 13, yes? Letter B, what's the cosine? So 3 over the square root of 13, which is going to be 3 square roots of 13 over 13. And C is going to be using the tangent. Well, how do I find the tangent? That's 2 square roots of 13 divided by 3 square roots of 13. Those cancel out to give you the 2/3. I don't have to use an identity. I know that, don't I? Right? Sine over cosine. That's what tangent is, sine over cosine. Now, letter D is going to be the secant of 90 minus theta. That is a cofunction. That is a cofunction, and I talked to you about these cofunctions. They're on page 269 of your textbook at the very bottom of the page. The secant of 90 minus theta is equal to what? The cosecant of theta. That's what your cofunction identity says on your level little, what is that thing, index card. So what is the cosecant of theta? Square root of 13 over 2. Yes? Yep, it's a cofunction. You look for the equivalence of it. The secant of 90 minus theta on page 269 at the very bottom is your cofunctions. That is equivalent to, that's what it says, is equivalent to the cosecant of theta. You just substitute that in. That's all you do. Okay? I would put those on your index card because I'm not going to give them to you. Yep. Okay. We good on all those? Okay, the next section, which is 21 through 28 or 29. These are all your identities, your proofs. So talk to me. What do we need to do? 26. 26. 1 plus the cosine of theta times 1 minus the cosine of theta is equal to sine squared of theta. What do you think we need to do? I would FOIL that. So if you FOIL this, you're going to get 1. What do you notice about these? It's the difference of squares. So what happens to my outer and inner? They cancel out. So I just have to do first. 1 times 1 is 1. And last, cosine times cosine is minus cosine squared of theta. Now, that looks very similar to something, doesn't it? Okay. What does it look like? Well, if you go back to your identities, what you need to know is that I need this to be sine squared over here, which means I need no cosines. Do we understand that? So I need to have a sine squared, but I currently have a cosine squared. So how do I get rid of the cosine squared? I have to take my identity, which is right here, and what am I going to solve this thing for? What do I need to get rid of? I need to get rid of cosine squared. So I'm going to take this identity, I'm going to solve it for cosine squared. So I'm going to subtract sine squared of theta from both sides here. So that gives me the cosine squared of theta is equal to 1 minus the sine squared of theta. So now every place I see a cosine squared, what expression can I plug in place of it or substitute in place of it? 1 minus sine squared of theta. So I actually am going to have 1 minus sine squared of theta. Now, notice I put that in parentheses. Why did I put that in parentheses? I'm sorry? Because I'm not substituting one term, I'm substituting how many terms? 2 terms. So if I'm substituting in 2 terms, I need to make sure I'm putting parentheses around it so I can distribute that negative. So when I distribute, I have 1 minus 1 plus sine squared of theta, correct? What happens to your 1s? They cancel out, and I'm left with sine squared of theta, which is exactly what I wanted. Do we see that? Notice I looked at the left-hand side, looked at the right-hand side, and I said, okay, I have cosines on my left-hand side, but I don't have any cosine squares on my right-hand side. I have all sines. So I need to somehow eliminate that cosine and get only sines. Well, the only way I can do that is by taking the trig identity, sine squared plus cosine squared is equal to 1, and solve that for cosine so I can get an equivalent expression. Yes? Okay. That is 26. So talk to me. Do I need to do another one? 29. Oh, 29's fun. I don't understand why nobody likes my proofs. Sine of theta over the cosine of theta plus the cosine of theta over the sine of theta is equal to the cosecant of theta times the secant of theta. Okay. You're right, it is tangent and cotangent, but does that really help me? I can convert sine of theta over cosine of theta into tangent, but then I'm left with tangent plus cotangent. We cannot touch the right-hand side. That right-hand side is frozen right there. Can't cross multiply because how are those two fractions attached? By addition. So when two fractions are attached by addition, what do you need to do? How do you add them? Common denominator. That is the correct solution. Okay, so what is my least common denominator between cosine of theta and the sine of theta? Absolutely. So I need this fraction to have that denominator, and I need this fraction to have that denominator. So talk to me. What did I multiply cosine by in the first denominator to get my new denominator of cosine times sine? So what you do to the bottom? So what is sine of theta times sine of theta? Sine squared of theta. Now look at the second fraction. What did I multiply sine of theta by to get cosine theta sine theta? Cosine of theta. So what you do to the bottom? So what does that give me at the top of the second fraction? Cosine squared of theta. Now folks, I have two separate fractions currently that have exactly the same denominator. We want to marry them. They want to move into the same house, right? The house is my denominator, which is going to be the cosine of theta, sine of theta. And then here comes her stuff, sine squared of theta. Here comes his stuff. We have one house now. You with me? An alarm should be sounding off in your head. What's it saying? Nope. That's a plus sign. Wherever cosine squared goes, sine squared tags along. Trig identities, trig identities, trig identities, trig identities. Anytime you hear me say a bell should be sounding off in your head, that's what I'm talking about, folks. You need to utilize those trig identities. So that entire numerator turns into what? It turns into 1. So I have 1 over the cosine of theta times the sine of theta. Still not done, am I? How can I rewrite that? Can I tear them apart? I can tear those apart and make that 1 over the cosine of theta times 1 over the sine of theta. True? Well, what is 1 over cosine? Secant. What's 1 over sine? Cosecant. By the commutative property of multiplication, 2 times 5 is 10, 5 times 2 is what? 10, so therefore I can swap the order of those, right? And make that cosecant of theta times the secant of theta. And that is what I wanted. Do we understand that? Now, I've referred to this example many, many, many times. There's many different seasons to kill deer, many different methods to kill a deer. As long as you're in the right season, unless it's car season, you're golden, right? My way is not the only way to do this. I took and I taught you this method for the simple fact that I was going off of what you have already learned previously in math. I built on something that was already had a foundation of adding and subtracting fractions, correct? Now, some of your heads immediately saw the tangent and the cotangent concepts. Agree with me? Chances are you're still going to have to translate that back into terms of sine and cosine and go this route again. I don't care how you do it as long as you prove to me what you're doing and the actual proof makes sense, okay? Questions? Any more? We have time to do another one if you'd like. I'm sorry? Number 6. $21 pi. Okay. Is this true or false that it's either going to land at 0 or pi? It's true, right? It has to. So your goal is to take this and continue to subtract until you land between 0 and 2 pi. Yeah, that's what you need. Yeah. This is going to be equivalent. Why do I know this? Because what if I take 20 pi or 22 pi, right? This is equivalent to 10 pi. This is going to be equivalent to what? 11 pi. Not 11. Yes, 11 pi. Do we understand that? Yes? Do we get that? If we keep going around that, so if I take 22 pi minus 21 pi, that's going to give me pi units, right? Pi units lands me at this ordered pair what? -1, 0. Agree? So if I'm at -1, 0, the sine of 21 pi is going to be 0. The cosine of 21 pi is going to be -1. The tangent of 21 pi is going to be 0 divided by -1 is 0. The cotangent of 21 pi is going to be what? Undefined. Do we understand that? And now what is going to be the secant? Put this over 1, it's still -1, right? What is going to be the cosecant? Put this over 1, and that's going to be 1 over 0, which is going to be what? Undefined. Undefined. Because I needed to get over 21. We have 0, we have pi, and we have 2 pi. Agree? This, I needed to make it a number greater than that. That was divisible by 2. So that's 20 or 22 because I'm looking at this right here, 2 pi. You with me? Nope. Do you understand that this was 0 degrees? This is going to be pi. This is going to be 2 pi. Because 21 falls right here. You with me? I needed it to be between 0 and 2 pi. If I would have just done this, would that have worked? I could have. I could have taken 21 pi minus 20 pi, and I still would have gotten what? Pi. I chose to take 22 pi minus 21 pi to get pi. It's the same concept. It's whichever way your brain works. It's still equivalent to pi. You with me? As long as you get pi, I don't care how you get it. Okay? Are we good? All right. That is the review sheet over packet 2. Now, I am going to stop recording. I'm going to show you guys the test now. So, what can you have on your lovely little note card? From section 4.1 all the way back. You may have S is equal to R times theta. From section 4.2, you may have the blue box on page 260, which is sine of t is equal to y, cosine of t is equal to x, tangent of t is equal to y over x. You may also have the even and odd functions. On sections 4.3, you may have the blue box on page 267, which is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You may also have on page 269 at the very bottom the cofunction identities. And then on page 270, the blue box, you may also have the entirety of that blue box. 269. It's the third time, girl. Okay? And that is everything you can have on your lovely little index card. No examples. Questions, comments, or concerns? Okay, test tomorrow.